Right, we have our first video, our guided notes on lines and triangle relationships. For section 1, we have intersecting lines and transversals. So our first video is just simply going to get some vocab down, or some of our notation here. So the first thing we have to figure out is, what is a transversal? Well, a transversal is a line that passes through two lines in the same plane at two distinct points. So in our example over here, we see we have two lines, M and P, and you're being cut right like this by line R. So in this case, we would say line R is our transversal. It's the one that's cutting through the other two lines there. Corresponding angles. The angles in matching corners when two lines are cut by a transversal. So we have our lines M and P. They are cut by a transversal, line R. So if I wanted to look at this intersection and this intersection right here, notice it's cut in, each one is cut into 4 different angles. If I wanted the top left one in this case, so that would be angle 1, the corresponding angle would again be the top left one, so angle 3. If I wanted the bottom right one over here, so angle 7, the corresponding angle would also be the bottom right one, so angle 5 over here. So we'd say angle 7 and angle 5 are corresponding, angle 1 and angle 3 are corresponding. Corresponding angles. Alternate interior angles. Angles inside the lines and on opposite sides of the transversal when two lines are cut by a transversal. Let's break this down. Alternate, that says they're going to be on opposite sides of our transversal. Interior, that means they're going to be inside of our lines. So interior means in here somewhere. Alternate means on opposite sides of our red line, the transversal. So 2 is an alternate interior angle with 6. They're on opposite sides of our red transversal. Same thing. 7 is an alternate interior angle with 3. They're both inside, so interior, of our two lines M and P. And they're on opposite sides of the transversal, so alternate. So if we use those definitions or use those cues, alternate exterior, well, the exterior part means that they need to be outside of these lines. The alternate part means that they need to be on opposite sides. So we might say 1 and 5. Again, a more specific definition would be the angles outside the lines and on opposite sides of the transversal. Okay, our other alternate exterior angles, 8 and 4. Again, they need to be outside of the two lines, opposite sides of the transversal. Alternate exterior angles. Our last piece here, same side interior angles. Okay, because they are interior angles, again, we're on the inside of these lines here. Because we're looking for the same side, we want them on the same side of our transversal. So 7 and 6 would be same side interior angles. 2 and 3 would be same side interior angles. Something to review, a linear pair. If we have two lines that intersect each other like this line here and this line here, a linear pair would be two angles that share a ray and a vertex, and each of their second rays is on the same line. So we might say angle 1 and angle 2. They have the same vertex right in the middle. They share this ray, and their other rays, these pieces here, create a line. So angle 1 and angle 2 are a linear pair. One other thing we know for sure about any linear pair is that they're supplementary. Angle 1 added on to angle 2 has to equal 180 degrees. are supplementary. Vertical angles would be the opposite angles made by those intersecting lines. So, for example, we'd say angle 1 is a vertical angle to angle 3. Angles 2 and 4 are also vertical angles. They're the opposite ones across from each other on those intersecting lines. Now, one thing we know about vertical angles, those opposite ones, they are congruent. So whatever angle 2 is, angle 4 is also that measure. Whatever angle 1 is, angle 3 is also that measure. They are congruent to each other. That concludes our vocab part.